This week's content focuses on our introduction to MIDI and MIDI sequencing. This week we will define the basics of MIDI and its origins. We will understand essential terminology associated with the MIDI protocol and discuss the essential pieces of a basic MIDI workstation setup. Musical Instrument Digital Interface, or MIDI, is an extremely useful and versatile way in which we can musically interact with digital musical devices. This module introduces us to the basics of MIDI and how it is applied to what we do in the studio. So far, we have discussed how to work with recorded audio, both in analog and digital formats. The digital audio workstation is essential to this process, as we know. However, a DAW can also create sound internally or from scratch. It can also synthesize sound itself. It typically uses software instruments or software synthesizers installed on it that can be controlled by the user so that we can create our own musical layers and textures. This function of a DAW relies upon a technology called MIDI. This week's content will focus on what MIDI is and how we use MIDI and a DAW together to create musical patterns. This process is called sequencing. First, we should think about how we interact with computers themselves, and in a general way. Computers and other digital devices are only able to understand data. Data, remember, is a series of ones and zeros. The ones and zeros relate to certain parameters associated with computer applications or programs. In order to interact with a computer musically, we need a musical interface. An interface is a device or program that allows a user to communicate with a computer. We use all kinds of interfaces every day to interface with or interact with digital devices. As a computer user, we regularly use interfaces such as a QWERTY alphanumeric keyboard or a mouse. A graphical user interface is a visual way for humans to interact with what the computer is doing with items such as windows, icons, and menus. Any human interaction with a digital device, like a smartphone, a tablet, computer, Chromebook, requires an interface of some kind. To work with a digital device in a musical way, we rely upon a musical interface called MIDI. MIDI is an acronym that stands for Musical Instrument Digital Interface. It is a standard protocol that we use to interact with a computer or digital device in a musical way. MIDI allows us to connect digital musical instruments or controllers to a computer, and also to connect digital music instruments or controllers to each other. In the 1980s, the development of the computer chip made digital technology more affordable, reliable, and accessible. If you recall, that time was when there was a very large boom in the production of digital chip technology and the availability of such. More and more computers were appearing in homes and businesses. More and more synthesizers were becoming digital and therefore more stable and affordable. Many manufacturers of synthesizers found that they were making interesting devices that they would like to connect to each other in a universal way, but they did not have the technology to do so. Because these instruments were digital, this allowed them a through line to connect these things together. In 1982, a group of digital synthesizer manufacturers worked together to create the MIDI protocol. It created a universal digital musical interface for all synthesizer and computer manufacturers to rely upon for the communication of music-specific control information. Much in the same way that USB alphanumeric keyboards are universal for all computers and devices, this created a way for all computers and devices to communicate with music or music information through controllers. Although MIDI was mainly used to control hardware synthesizers originally and to program desktop computers to create MIDI sequences, we still rely on MIDI today to perform lots of tasks. In the picture here, we see an older setup from the 80s and probably the 1990s, in which we have a series of digital synthesizers and a desktop computer with an analog mixer and an analog patch bay. Through MIDI, the computer can interact with the outboard synthesizers to create sound and sequences. On the screen, we can see a sequencer on the CRT monitor on the desk. The sequencer allows us to enter information associated with MIDI so that the computer can send it to all these instruments. The audio output of all the synthesizers then are patched through the patch bay to the mixer on the desk. The mixer then gives us a unified stereo output that then goes to the studio monitors. However, today, we use MIDI in other ways, most basically to connect a MIDI controller to a computer to control software instruments. With the evolution of technology, even MIDI has become more and more reliable and universal. The gear that we use in the MIDI realm has also become more and more affordable and compact and user-friendly. A MIDI controller is a device that allows humans to enter musical information into a computer. The software instrument on the computer is a virtual instrument stored on a digital device that listens for this MIDI information to create sound. These days, we typically use a universal serial bus cable, or USB cable, to connect MIDI controllers to software instruments. At this point, it's important to remind ourselves that MIDI is not digital audio. Digital audio is its own realm of data stream. MIDI is, however, a control information data stream. The sounds come from the virtual instrument stored on the digital device, not from a MIDI controller. A MIDI controller on its own does not create sound. It relies upon the software instrument installed on a computer. To make a digital device create sound from scratch, we need to control it with a MIDI controller. A MIDI controller is a device that sends MIDI data to other MIDI-compatible devices to trigger sounds and control parameters. MIDI controllers do not create sounds on their own. They simply send control information to the computer so it can make sound. MIDI controllers come in all shapes and sizes. They usually mimic piano keyboards, and they can also have pads, knobs, sliders, and other control devices. Here we have pictured a few different kinds of MIDI controllers that are based on the keyboard model. Note that they both have pads and knobs that can be MIDI mapped to parameters on screen to allow us to musically change or trigger sounds in a DAW. MIDI controllers send control data to a digital device. Therefore, they connect to a computer or digital device via data cables, not audio cables. Since 1982, MIDI has used MIDI cables, or a 5-pin DIN socket and plug cable system, to communicate with digital devices. These are still found in studios today and remain quite useful. MIDI jacks, however, are one way and are labeled MIDI in, MIDI out, and MIDI through. This system of MIDI cables and jacks, although outdated today, is still found on lots of gear and is still useful today. However, most modern MIDI devices connect to digital devices via a standard USB cable, which is much more convenient and user-friendly. It transmits in a two-way data connection, which is also very fast, and we can supply power to the device via the USB cable. The MIDI devices that are powered by the USB cable are considered bus-powered. Bus-powered MIDI devices do not require an additional power source and cable. Here we have listed the different kinds of MIDI connections. On the top right, we have a picture of the 5-pin DIN socket that is our original MIDI cable and the plugs. And then below, we have the 4 types of USB cables that are available today. USB-A and B, USB-C, mini USB, and micro USB. Today, more and more devices are using USB-C connections. A MIDI sequencer is a computer program that records, edits, and plays back MIDI data. MIDI sequencers can be hardware devices, but are more commonly software programs that are installed on a computer or digital device. MIDI sequencers allow us to record, edit, and play back a MIDI sequence either to be played by an external MIDI-compatible synthesizer or a software instrument. Regardless, these instruments are designed to listen to MIDI data and respond by creating sound. MIDI sequencers are found in most DAWs available today. Above, on the top right, we have a view of Ableton, and on the bottom right, we have a view of Logic, both of which have not only audio recording capacity, but also MIDI sequencing. When we use a DAW to create a MIDI sequence, we often have a choice of how to view this control information in a timeline on screen. There are 4 basic MIDI sequencer views. The most common is the piano roll view. The piano roll view is modeled after the mechanical player piano technology from the early 20th century, where the piano roll shows the notes, duration, and velocity of each MIDI entry in time. Each MIDI entry references pitch, low to high, on a grid. We typically see a vertical representation of a piano keyboard on the left side to show low to high range of notes. And then, of course, the left to right axis is time. We can also use a clip or loop view. This is becoming more and more common, and as such, it shows us how looping blocks interact to create a section of music. Individual notes are typically not shown in this view. Rather, we are looking at phrases. Most sequencers also have a notation view. This view shows how your sequence would look in standard music notation. Music notation software available, such as MUS Score, Sibelius, and Dorico, use MIDI just like a sequencer to create music notation. Logic and other programs that also provide a notation view are not known for their ability to notate music. However, if it's helpful, they do provide that view for us to see the actual notes on a staff. Finally, the event list shows us a simple list of all the MIDI data in a vertical text-only format. Sometimes this is useful for batch processing of MIDI data or for searching and finding a specific note.